Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, basically, today, I would like to discuss on the implementation of the subject. And before that, uh, this is BKC 2453 Communication System, and my name is Izrin Farina Shae. So I'll be teaching you guys 2B EKG Section 3 and also 2B EKG Section 2 and also part-time student. And I am also the coordinator for this subject this semester. Okay, so So before we start with the implementation, before I explain on the implementation, so this is the brief introduction about myself. So my name is Izrin Farina Shae, and I've been with UTM since 2011. And this is my education background. My major in during my degree is in control instrumentation. My master's majoring in mechatronics and automatic control, and my PhD is in electronics engineering. So the important thing that I want to highlight in this slide is this one. Okay, so if you have anything, any questions about the subject, you can directly WhatsApp me, or you can just post the questions in the Telegram group. Okay, so my phone number is 019-394-6175, and my email, you can also contact me through my email, isrin@utam.edu.my. Okay, so my room is at block A. So since this is you are not in UTM, so I don't think that you need the room number. Okay, so again, I want to remind you, if you have any question, feel free to contact me through WhatsApp personally or in the Telegram group. However, it is advisable if you can contact me during office hour only, meaning 8 to 5. Okay, so unless you have very important issues that requires you to contact me after 5 p.m. Okay, and these are the rules, several rules for the class, for this subject. Actually, this slide is for the face-to-face lecture. However, kita juga masih takluk with this kind of rules lah. Okay, so the first one is do come early. So do come early here means that please join the online class on time. Okay, so usually I will tells you beforehand. For example, today, okay, so your timetable actually from 2 to 4 p.m. However, I already informed you earlier that we will start at 2:30. Okay, so you must make sure that you join the online class exactly at 2:30. Okay, and the second one is feel free to ask me any questions through WhatsApp or Telegram. You can Okay, you can just ignore the third one. But the fourth one here is the most important thing that I want to highlight, is that you must be honest when you are doing your test, your final exam, and also your quizzes and your assignment. Okay, because we receive, not receive here, but we detect that there's a lot of plagiarism or cheating happens during online tests and also online final exam. So maybe in the previous semester, you were not caught. If in the previous semester you cheat during your final exam and you dan tak ditangkap, so but if ditangkap, you will be penalized not by me but by the university. Okay, so I really hope for this subject this semester, you must be honest during your final, when you are doing your test and also your final exam and also your quizzes. Okay, so this one, this is the slide on outcome based education. I don't think I want to explain on the outcome-based education today, because I think in the previous lecturer already explained to you on what is OBE, okay, every semester. Okay, so basically I just want to explain on your teaching plan. Okay, and before that, so I hope that you already log in into your ULearn. Okay, so this is your ULearn for BEKC 2453 communication system. So if you look at your ULearn, you can see that I've already updated. This is the general info. Okay, so this is the link for the Telegram group and the Microsoft team, and this is for the recorded lecture. So please make sure that you join the correct group. Do not join both. For example, you are section 3, join section 3. Do not join section 2 and also section 3. Okay. Same for the Microsoft Teams. And for the recorded lecture, this one usually after class, I will upload the video lecture for that day in my YouTube channel. Okay, so you can access it from here. And I also uploaded it inside the ULearn. Okay, so you can rewatch the lecture in ULearn and also in the YouTube. Okay, and if you look at here, this is about me. Okay, and over here, I've already uploaded the teaching plan. Okay, so this is the teaching plan. So if you want to download, I have already uploaded the Excel file for the teaching plan. Okay, so this is the teaching plan. Okay, so for this subject, I hope that you guys already know what is learning outcomes. Yeah, so learning outcomes is the outcomes that you need to achieve at the end of the class for this semester. Okay, the things that you need to achieve. So for this subject, we have 3 learning outcomes. Okay, so the first one is that you must be able to describe the basic principles of analog and digital communication, data and computer network. And the second one, you must be able to analyze the analog and digital communication techniques that are typically used in communication system. Okay, and the third one is you must be able to explain the concept of your computer system network. Okay, so if you look at the learning outcomes over here, you look at the first word. Okay, this is describe, this is analyze, and this is explain. Okay, so from this learning outcomes, you can directly know that the learning outcomes for LO1 will test in terms of your theoretical knowledge. LO2 involves calculation. LO3 explain, so it also involves theoretical knowledge. Okay, so basically this learning outcome is like the benchmark. Okay, you need to benchmark yourself whether at the end of the semester whether you already achieve or satisfy all the LO 1, 2 and also 3. Okay, so these are the synopsis of the subject. You can read it by yourself, and this is the references. So over here in the teaching plan, I've already listed 5 references. Okay, and the references number 1 and number 2 is the U10 module. Okay, so if for example you want to purchase these 2 module, maybe you can try to contact the Penerbit University whether they still have it, because this 2 modules is first published in 2013 and now it's already 2021. Okay, but you can still contact the Penerbit University whether they still have it. And basically this one, reference number 1 is for the analog communication. Reference number 2 is the digital communication. Okay, so basically this subject, it will consist analog communication, digital communication, and also this computer system network. Okay, and this is the course implementation. We will have 3 hours lecture every week, and also tutorial. Tutorial is not every week, yeah. And also we have the assessment. Okay, so this is the course evaluation. Okay, so for this subject, you can refer here. For the assignment, it will consist 15 marks, and from this course evaluation, you can actually know, or you can actually spot which question will be asked. For example, assignment, okay, this is 15 marks. So if you look at here, it will cover LO3. So you look at LO3 here. LO3 is explain the concept of computer system network. And this computer system network is covered in the last chapter, which is chapter 5, if I'm not mistaken. Okay, so you should expect that your assignment is based on chapter 5, the final chapter. Same goes to the quizzes. Okay, so quizzes, we have 2 quizzes, 2.5% each. Both will cover LO2. So if you look at LO2 is analyze. So analysis, so it involves calculation. I will not ask theoretical questions in the quizzes. Okay. For your midterm test is 20%. We have question 1, question 2. So we have a combination of theoretical and also analysis. And also the final exam, we have 4 questions. Okay, for this semester final exam, I decided to have 4 questions, answer 4 for the final exam. Okay. So 15% each. So if you look at here, the question number 2 mentioned here is 10% for WP1. So WP1 is complex problem solving. Okay, so please expect that for question 2 in your final exam, it will consist of complex problem solving question. Okay, so the total marks will be 100%. And this is your syllabus. Okay, so if you look at here, this is week 1. So week 1, we will cover chapter 1, part 1. Okay, so basically, usually, for example, for week 1, usually, I will try to finish the syllabus for that chapter in 1 session. Meaning, for part 1, I will try to finish the syllabus in the first class. Okay, how so that we don't have the session for the second class in the same week. Okay, however, but if for example I cannot finish the syllabus in 1 session, then we need to have another session on Friday. Okay, so I hope you understand that. Okay, so for example, today, I don't think I can finish the syllabus because I have a meeting after this. So I will continue the lecture for part 1 on Friday. Okay. So for week 2, you look at here, for week 1, we don't have any tutorial, but for week 2, next week, we will have tutorial 1. So for the syllabus, you can refer to this Excel file, detailed syllabus and delivery planning. Okay, I already stated when is your quiz. So your quiz 1 will be on week 5. Midterm examination, this one actually depends on the university. Okay, but usually it is on week 7. Okay, and also we have quiz on week 11. Assignment and also final exam. Okay. So do you have any question regarding your regarding the teaching plan?
No.
Okay. So okay, so any all the apa? Okay, so if you look at here, this the main communication medium for this subject is the ULEN. Okay, so please make sure that you join the correct class lah. So for this semester, Dr. Rahim will handle section 1. I will handle section 2 and also section 3 and also part-time. And I am also the coordinator for this subject. Okay, so all the notes, tutorials, I will upload it in the ULEN. Okay, also for quizzes and tests, I will also use the ULEN. Okay, and another thing about the ULEN, so if you log into your ULEN, okay, so if you look at here, week 1 over here, this is the learning outcome for week 1, which is explain the concept of electronic communication system. So this one I already uploaded the lecture notes. This is the chapter intro to OBE. This is the chapter 1. Okay, chapter 1 part 1. And for the attendance for this class, because this is the online lecture, so for the attendance, I will saya akan ambil kira weekly. Okay, so you need to fill this, the weekly summary, leave some summary or comments on the subject for that week. Okay, so if you write the summary or the comments here, then I will regards that you attend the class for that week. Okay, so please make sure that you remember to leave feedback or comments in the ULEN. Okay, so if you don't have any question, I think I want to start on chapter 1. I will not finish chapter 1 by today. Okay. So for chapter 1 here is introduction. Okay, introduction to electronic communication system. So over here it stated that the purpose of electronic communication system is to transfer information from one place to another. Okay, transfer information from one place to another. So the important thing here is transfer information one place to another, meaning that the purpose is to transfer information and you need to have 2 or more places or points. Okay, so for example, like I am talking to you right now. Okay, so I am actually transferring information. Okay, so I am over here, you are at your home. Okay, 2 different places. Transfer information from one place to another. So this is called communication system. Okay, so and that is this basic concept of communication system. But when we talk about electronic communication, okay, when we talk about electronic communication, it can be viewed as a transmission, the reception, and the processing of information between 2 or more locations using electronic circuit. Okay, so when we talk about electronic communication, it involves the details, okay, the process of transferring the information from one place to another. So in this chapter, we will cover communication models, communication transmission modes, power measurement in electronics communication, electromagnetic frequency spectrum, communication bandwidth, and also information capacity. So if you have any questions during the lecture, you can directly ask here. You don't need to wait until the end of the lecture. Okay, so this is the basic communication model. Okay, so basic communication model consists of three important things. The first one is the source, the second is the destination, and the third one is the channel. Okay, so this is the block diagram of a basic communication model. Okay, and you should note the function of each block. Okay, so for example, the first one here, this is the source. Okay, source is the sender of information. For example, I am currently communicating with you. Okay, so the sender is me. Okay, I am the one that is sending the information. And then you have the sink or the destination. Okay, we call it as destination or sink. The sink is the receiver that will receive the information, which is you. You are the one who received the information. Okay, and in between we have the channel. So the channel here is the transmission path or medium of the information between the source and also the sink. Okay, so for example, I have a questions. For example, this is you and this is your friend. Okay, and you are actually talking to each other. Okay, you are talking to each other. Can you give me what is the transmission medium or the channel for your communication system over here when you are talking?
Gelombang.
Gelombang. Okay, okay, bolehlah, correct. Okay, so gelombang, actually it is air. Okay, example, can you give other examples of communication channel that you know for electronic communication?
Smartphone.
Internet.
Yeah, but that one is not transmission medium. Okay, so the transmission medium or the transmission channel example is copper wire. Okay, example of transmission channel is we have copper wire. We also have, if you use your Unify, so your channel is fiber optics. Okay, and if you are talking to your friend directly, then it is air. Okay, so these are example of transmission channel. Okay, so I hope that you understand the function of each block. Okay, so that one is the basic communication model. Okay, but if you were asked to draw the communication model, you need to draw this block diagram. Okay, so this and this block diagram is similar. Okay, but this is more detailed. Okay, so in this this is communication system model. So you still have the sender, you have the recipient, and you have the channel. Okay, but in between you have extra modulator, transmitter, receiver, and demodulator. Okay, and it is very important for you to understand the function of each block here, over here. Okay, so for example, I give you the same example. So I am talking to you right now, okay, using Microsoft Teams, meaning online. So the sender here is me. Okay, so the input is what signal?
Microphone.
Yeah, but what signal? Microphone is not a signal.
Waveform.
Voice, okay? The input signal is my voice, suara saya, my voice signal. Okay, so my voice, the input here will go to the modulator. What is the function of modulator? If you look at here, to transform the source signal, which is the voice signal, so that it is physically suitable for the transmission channel. Okay, so currently the voice signal is not suitable for transmission channel, so we need to convert it. Okay, so that is the function of modulator. So the modulator actually converts the input signal, which is the source voice signal, into electromagnetic energy. Okay, so this modulator will convert the input signal into something that is suitable for the channel. Okay, and then after it converts the signal, then it will send it to the transmitter. Okay, so transmitter is used to introduce the modulated signal into the channel. It also acts as an amplifier. So I hope that I'm sure that you guys already know what is the function of amplifier. Okay, to increase the amplitude of the signal. Okay, to increase or decrease the amplitude of the signal. Okay, so this transmitter will introduce the signal through the channel and the receiver will receive it. Okay, the receiver detect the signal on the channel and amplify it. Okay, and then the signal will go to the demodulator over here. So if you look at here, this is modulator, this is demodulator. So you should know that the function is the opposite. Okay, demodulator, the function is opposite to the modulator. So modulator, it converts input signal into signal that is suitable for the channel. Demodulator, it converts the modulated signal into the original signal. Okay, it converts the demodulated signal into the voice signal again. So that's why you can hear my voice right now. Okay, so the input is voice signal, the output is voice signal, but in between, during the processing, it is not voice signal, it is actually electromagnetic energy. Okay, so I hope that you understand the concept of communication system. Okay, and later on we will learn in detail on types of modulator. Okay, so for example, this modulator, we have several types. We have amplitude modulator, we have frequency modulator, we have phase modulator. Okay, so this one we will cover in the other chapters. Okay, for example, AM is in chapter 2, FM and PM will be covered in chapter 3. Okay, but right now you just need to understand the process of the communication system. Okay, and A communication system, it can be designed to transmit information either in one direction or both direction. Okay, so basically there are three types of communication modes. We have simplex system, we have half duplex system, and also we have full duplex system. So the simplex system is that it is a system capable of sending information in one direction only. Okay, so in one direction only. So only one sender, only the sender can send the information, and the recipient can only receive the information. So for example, television and also radio. Okay, so television, the TV presenter, it can send the information to you. Okay, and you can receive the information, but you cannot send the information to the television. Okay, so this is what it means by simplex system. Same for the radio broadcasting. Okay, you can send information in one direction only. Okay, for half duplex system, the system is capable to carry information in both directions. Okay, but only one direction is allowed at a time. Okay, so you can send both direction, meaning I can send information to you, you can send information to me. Okay, however, only one direction is allowed at a time. So for example, you have the walkie-talkie. So I'm sure that you know what is walkie-talkie, right? So walkie-talkie, for example, uh, you can use the walkie-talkie to send information in both directions, but I need to send the information first, then I stop, then only you can send information to me. Okay, you cannot send information simultaneously. Same like the two-way intercom. Okay, so I hope that you understand the difference between simplex and half duplex. Now let's look at the full duplex. So full duplex here, it can carry both directions at the same time, meaning simultaneously, like right now. Okay, so I can send information, and at the same time you can also send information to me. Okay, so example, mobile phone and also computers. Okay, so these are the difference between simplex system, half duplex system, and also full duplex system. So simplex system, one direction only. Half duplex system, both direction, but one direction at a time. Full duplex system, both direction simultaneously. Okay, so next, this is the difference between half duplex system and full duplex system. Okay, so in the previous slide, you already know that the difference is that half duplex cannot send information at a time. Okay, full duplex can. But if you look at here, this is more detailed. Detailed apa? Perbezaan between half duplex system and full duplex system. So if you look at here, for the half duplex system, it uses limited bandwidth, limited number of wires, and limited signal channels. Okay, limited meaning smaller number of bandwidth, smaller number of wires, smaller signal channels. Full duplex system, it requires twice as much bandwidth as a half duplex path, meaning full duplex, it requires double the bandwidth for half duplex. Because, so if you look at here, for example, this is the channel, yeah. The channel is like the path, transmission path. It's like the road. Okay, so half duplex, remember, half duplex can only send information at a time. Okay, only one direction at a time. But for full duplex system, this is half duplex, yeah? Half, and this is the channel, transmission channel. For full duplex, this is the transmission channel. So it can, the information can be sent in both directions simultaneously. Okay, so this is the full duplex system. Okay, so if you look at here, because this one, it can only send one information, one direction only, this one simultaneously. So you can see that the channel here, this is, you have a smaller channel, this is bigger. That's why the half duplex system, it requires smaller bandwidth. Okay, smaller bandwidth. Full duplex system, it requires double the bandwidth of this full duplex, a half duplex system. Okay, and half duplex system also requires smaller number of wires and also signal channels. Okay, so why? If you look at here, half duplex system, it shares the same bandwidth. Okay, so it shares the same bandwidth, so that's why it can use smaller bandwidth. Okay, but for full duplex system, the users do not have to take turns. Okay, so it doesn't share the bandwidth. Thus, the bandwidth need to be twice as much as the bandwidth of the half duplex. Okay, and for the half duplex system over here, half duplex system is used if there's a need for two-way information flow. But if you want to have a two-way information which is more convenient and more efficient, then you need to use full duplex. Okay, and next, okay, so since this is the communication system, so the communication system, remember I told you that the modulator, the function is to change the input signal into a signal that is suitable for transmission channel, which is the electromagnetic energy. Okay, so when we deal with electromagnetic energy, the parameter that we will deal with is the power measurement. Okay, this is the parameter that we usually use, which is the power measurement, and the unit is dB, dBm, and also bel. dB here is decibel, decibel. M here is milli. Okay, so over here is stated that the magnitude of communication signals span a very wide range. Okay, the range of the communication signal is very, very wide. Okay, thus it will cause several drawbacks. For example, so since the range of the communication signal is very wide, then if you, for example, you wanted to draw the signal, okay, you need to use extremely large scale. Okay, and also since the range of the communication is very wide, then the calculation will involve very hard calculation, because the numbers, it could be either too big, it could be either too small. Okay, and it will prone to errors, because if, for example, if the numbers is very small, like 0.0001, okay, you may mistaken it as 0.00001. Okay, so this is what it means, and it is hard to compare the signal. So to to improve this, okay, to avoid these drawbacks, then the solution is the logarithmic scale, log scale. So I think that I think all of you already know what is logarithmic, okay, log function. So you have the log function in your calculator. Okay, so to calculate for the log, you can just use your calculator. Okay. So now let's look at the first here, the first unit here. This is decibel. So today I will only cover on the decibel. On Friday I will cover on dBm and also bel. Okay. So the first unit is decibel, dB, and this is also the units that we usually use. Okay. So decibel, it is used to measure ratio between two values. Okay, value to be measured relative to a reference value. Okay, so for example, you have two values, you want to measure the ratio, then you can have the ratio in decibel. Okay. And it also said that in the electronic communication field, decibel is normally used to define the power ratio between two signals. Okay, so the function of decibel is used to define power ratios between two signals. This is the first one. It also can be used to express the gain and also the loss of the electronic device circuit. This is the second one. And also describe the relationship between signal and noise. This is the third one. Okay, so decibel, the unit decibel can be used to define power ratios between two signals. It can also be used to express the gain and losses in electronic circuit. And the third one, it can also be used to describe relationship between signal and noise in a circuit. Okay, signal to noise ratio, SNR. Okay, so over here, it stated that if two powers are expressed in the same units, for example, watt and milliwatt, okay, the unit is watt, their ratio is dimensionless quantity that can be expressed in decibel form as follows. Okay. What it means over here, so for example, if you have two signals, okay, for example, you have two signals, you have signal 1, P1. This is the power of signal 1. And you also have P2. P2 is the power of signal 2. What is the unit for power? What is the unit for power?
Watt.
What?
Okay, so power 1 is what? Power 2 is what? So if you want to find the ratio between P1 power in signal 1 and signal 2, so you can divide P1 divided by P2. So this is what and this is what. Okay, you divide P1 divided by P2, you will get the value. What is the unit here? No unit, dimensionless, no unit. But if you use this formula, okay, this one, you multiply with 10 log, the value here, you multiply with 10 log, multiply with the value, this value, P1 over P2, you will get the ratio in decibel. This one, you will get the ratio with no unit, dimensionless. But if you multiply it with 10 log, you will get the ratio of P1 and P2 in decibel. Faham
Faham.
Okay, so you need to multiply with 10 log. So this one I already explained before. So the dB shows the difference in dB between power P1 and also P2. Okay, it shows the difference between P1 and also P2. Okay, so remember in this slide, Okay, I already highlighted that decibel can be used to define the power ratio between two signals. Okay, so this one, define power ratios between two signals, so you can use this. But it can also use to express whether the circuit is having gain, power gain or power loss. Okay, so how to determine whether the circuit having a power gain or power loss? Just by looking at the decibel unit. Okay, so this one you will use this formula. This formula is actually similar to the previous one, but the previous one, the formula is 10 log P1 over P2 because you want to measure the ratio between two signals. Okay, so it could be P2 and P3, P4 divided by P3. Okay, depends on your signal. But if in the case you want to measure the power gain or power loss in the circuit, you need to use this formula. Similar to this one, similar but it's not the same. Okay, the difference is over here. This one is P out divided by P in. Okay, so because you want to determine whether the circuit have a power gain or power loss, that's why you need to know the power value at the output and also at the input. Okay, so if the power at the output is higher than the power at the input, so you know that there exists power gain in the circuit. But if the power output is smaller than the power at the input, then you know there exists a power loss in the circuit. Okay, faham eh? So over here, so if you use this formula, okay, you will get a value in the unit decibel. Okay, but it could be positive, it could be negative. So if the answer you get a positive dB, then it is actually indicates that the output power is greater than the input power. Okay, so power is greater than the input, so meaning it indicates a power gain or amplification. Okay, the power increase. But if the value here you get a negative value, then it actually indicates that the output power is less than the input power. Okay, which indicates that there exists a power loss or attenuation. The power reduced. Okay, and another one, if the P out and P in here is the same, okay, if P out and P in is the same, so P out divided by P in, you will get the value 1. Okay, okay, so 10 log 1, you will get the 0 dB. Okay, so if you use your calculator, you try to key in 10 log 1, you will get the answer 0 dB, or we call it as unity power gain. So if your answer is 0 dB, then you should know that the output power and the input power in the circuit is the same. Okay, there is no power gain or power loss happens in the circuit. Okay, so next, so this table, just want to show you the power gains and power loss. So if you look at here, for example, this is the absolute ratio. The absolute ratio is the P1 divided by P2 or P out divided by P in. Okay, so if the absolute power ratio is 1, so 10 log multiply with P1 over P2, this is 1, you will get equals to 0 dB. Same as the others. So if you use 10 log 1.26, you will get 1 dB. If you calculate 10 log 10, you will get 10 dB. This one, so if you look at here, this is positive values, this is negative values. This is power gain, this is power loss. So if I hope that you can see the difference here. So if the ratio, look at here, if the ratio is bigger than 1, you will get a positive dB. But if the ratio P1 over P2 is less than 1, okay, 0 point something, you will get a negative dB, which means there's this power loss. Okay, very simple. For chapter 1 is quite simple, but please don't expect that the question for your test will be straightforward. Okay, yes, it is simple, but don't expect that the question will be straightforward as simple as in your slide. Okay, so now let's try and do example 1. Okay, convert the absolute power ratio of 200 to a power gain in dB. So can you please try example 1? Convert the absolute power ratio of 200 to a power gain in decibel. Try and do this and give me the answer in decibel. Anyone wants to answer example 1?
23.01.
23.01. Yeah, correct. Okay, so the answer for example 1 is 23.01. Okay, so siapa yang jawab tadi?
Ama.
Okay, so if you look at here, this is the power ratio. So power ratio is P out over P in. P1 or P1 divided by P2. But since the question asks you about power gain, then the power ratio is actually P out over P in. Okay, so P out over P in is equals to 200. Okay, so remember your formula. A P dB is equals to 10 log P out over P in. So 10 log P out over P in is 200. Just use your calculator, you will get 23.01 dB. Okay, next try example 2. So example 2 is the opposite of example 1. Okay, given the power gain in dB, the question asks you to find the absolute power ratio. Okay, so do you have the answer for example 2?
1000.
Yeah, okay, 1000. Okay, so how the calculation for this one is that the same formula. Now you have 30 dB is equals to 10 log P out over P in. Okay, so 30 divided by 10, you will get 3 is equals to log P out over P in. Okay, so how to solve for this one? Remember, I think you already learned this in your school. Okay, you have A equals to log C. So 10 to the power of A is equals to C. Okay, so 10 to the power of 3 is equals to P out over P in, which is equals to 1000. Okay, so this is the answer for example 2. Okay, semua boleh faham So
Faham.
okay, so next I want to proceed to the next slide. So in the previous slide shows you how to express power gain or power loss in terms of power ratio. Okay, remember P out divided by P in. That is based on power ratio. But if for example, if the question gives you the voltage instead of power, you can still calculate for the power gain or the power loss. Okay, so how? So remember, can anyone give me the formula for power?
P equal to IV.
P equals to IV. Other than that, P equals to V squared over R. Okay, so power, you know that P equals to V squared over R. So from this formula, you know that P is directly proportional to V squared. Okay, so that's why you have this. P is directly proportional to V squared. Okay, so if for example, you were given V out and also V in, okay, you want to calculate whether there's this power gain, then you can use this formula. So previously you have 10 log P out over P in. So you just change P out to V out squared, P in to V in squared. Okay, so you will get 10 log V out squared divided by V in squared. Or you can use this formula. So it is basically the same. It's just that this one you don't have the squared over here, but multiply with 20. Okay, so you can use both. You can use both formula. Okay, so any question? So at first, I wanted to stop today's class here. However, because we have another 30 minutes, I think I want to continue another 3 slides. Okay. So this is decibel. Other units is the dBm. Okay. This is dBm. So dBm is a unit of measurement used to indicate the ratio of power level with respect to a fixed reference level. So with dBm, the reference level is 1 milliwatt. So remember, for dBm, the reference level is not fixed. For dB, the reference level is not fixed. Okay, it is 10 log P1 over P2. Okay, so the reference, this is the reference, yeah. The reference is not fixed. It could be P3, it could be P4, it could be P5. But for dBm, okay, you have M over here. The reference level is fixed at 1 milliwatt. Okay, so 1 milliwatt is 0.001. Okay, so for if you want to have the unit in dBm, then you need to use this formula, 10 log power divided by 0.001. So now let's do example 4. Convert a power level of 200 milliwatts to dBm. Okay, so this is very simple. Just directly use the formula. dBm is equals to 10 log. The power is 200 milli divided by 0.001. So you will get 23. You will get 23 dBm. 23, the unit is dBm. Okay, so now try and do example 5. The opposite of example 4. Convert 30 dBm into an absolute power. Meaning find the P.
Satu.
1, yeah. 1 watt. Okay, so the answer for example 1 is 1 watt. Okay, so how to calculate that? This is 30 dBm equals to 10 log P over 0.001. So 30 divided by 10, you will have 3 log P 0.001. Okay, so 10 to the power of 3 is equals to P over 0.001. And P is multiply 10 to the power of 3 multiply with 0.001, so you will get 1. And don't forget the unit for power, which is watt. Okay, 1 watt. Okay, so next is this one. Dah salin eh. So next is dB. This table. This table is just to show you positive dBm and also negative dBm. Okay, so dBm values for powers equals to or greater than 1. Sekejap ya. Masih ada yang baru nak request Microsoft Teams. Okay, so this one, this table 1.3 is dBm values for powers equals to or greater than 1, and this one is dBm values for powers equal to or less than 1. So this one you can see that this is all, you will get negative. And the last unit is bell. Remember, you have decibel, you have dBm, and you have bell. Okay, so this is the last unit. So bell is actually 1/10 of a decibel. 1/10 of decibel. So you will get bell. So you look at here, this is similar to decibel, but without the multiply with 10. There is no 10 in front here. Okay, so bell is log 10 P out over P in. How do you get this formula? Okay, so over here is stated that bell is equals to 1/10 of a decibel. This is bell. It is 1/10 of a decibel. So you know that for decibel you have 10 log P out over P in. For bell, so this bell here is 10 log P out over P in. Divide by 10. Okay, divide by 10 because it's 1/10. Okay, so you can cancel this, so you will get log P out over P in. So that's why you get this. Bell is equals to log P out over P in. So this is just some history. The decibel unit was originated from the bell unit. Okay, decibel berasal daripada unit bell. Okay, and it is in honor of the Alexander Graham Bell. Okay, so the bell unit comprise absolute ratios of 0.000001 to 1,000,000,000 to a ridiculously low range of only 16 bell. Okay, so it is very difficult to relate bell unit to true magnitudes of large ratios and impossible to express small differences with any accuracies. So that's why, to overcome the disadvantage of the unit bell itself, so the bell was multiplied with 10, which it is then creating a decibel. So that's why usually in communication system we use decibel instead of bell. Okay, but it is originated from the unit bell. Okay, so if the question asks you to find the ratio in the unit bell, then you need to use this formula lah. You don't need to multiply it with 10. Okay. So that's all. I think we can stop our class for today. So because I have a meeting at 4, so I need to stop now. So on Friday we will have another class. So we will start this subchapter 1.3.4. So on Friday you have class 10 to 12 p.m. Okay, however for this week, only we will start at 11 a.m. Okay, so please take note that this week on Friday we will start at 11 a.m. because I have a meeting 9 until 10:30. Okay, so this Friday only 1 hour class. Okay, so any question for this today's lecture?
So far, so good.
Okay. Okay, so if you don't have any question, I think we can end our class for today and okay, end our class for today. So you can just fill in the attendance in the ULearn either today or on Friday lah. Okay, it doesn't matter. Okay, so thank you very much and see you on Friday.
Thank you, Doctor.
Thank you, madam.
Welcome.
Thank you, madam.
Thank you.
Thank you, Doctor.
Thank you, doctor. Doctor.
Okay.